All right, so picking up where we left off with from 11.1, which was graphing sine and cosine functions. So the remaining trig functions we have to graph would be cosecant, secant, tangent, and cotangent. And we're going to graph all of these today. It seems like a lot, but you will hopefully notice that tangent and cotangent are really the only new graphs we're introducing today, because cosecant and secant, the reciprocals are going to look pretty similar to what we were doing with sine and cosine. So if you remember that cosecant of theta is just the reciprocal of sine, and secant of theta is just the reciprocal of cosine. We're going to use those two definitions and properties to help us graph these functions, because we need to remember then that cosecant and secant of certain angles are undefined, where cosine of theta and sine of theta equal 0. Because these are the reciprocals, if sine of theta and cosine of theta equaled 0, well, 0 over anything, let's just call it 1 for now, the reciprocal would be 1 over 0, and we know anything divided by 0 is undefined. Okay? And when we have undefined relationships on graphs, we're going to have asymptotes. So you're going to see what these look like here in just a sec. Let's first illustrate a few other things on here. Let's find a couple trig functions. Let's find the sine of pi. Evaluate a couple of these trig functions. Sine of pi, sine of 2 pi, and let's do the secant of pi over 2, cosine of pi over 2, and cosine of 3 pi over 2. And I'm actually going to shift these all down just a little bit, because up here, I'm just going to put a little sketch of our unit circle and remind us of all of these points on our unit circle. Remember, what's a radius of 1 here at 0 degrees or 0 pi radians? Our units would be 1, 0, 90 would be 0, 1, negative 1, 0 for 180, and then 0, negative 1 for 270, or 3 pi over 2. So with that being said, the sine of pi, remember pi radians is 180 degrees. The sine of pi would be 0, right? The y-coordinate over here at negative 1, 0 is 0. Therefore, the cosecant of pi would be undefined because of what we stated up above, right? Great. If we continue around to 2 pi, same thing. The sine of 2 pi or the sine of 0 pi, these are both 0, so then the cosecant of 2 pi or the cosecant of 0 pi would be undefined. Okay? We'll see what that looks like on the graph in just a sec. Let's go look at cosine. Cosine of pi over 2. So for cosine, remember cosine is x. Up here at 90 degrees, 0, positive 1. Down here at 3 pi over 2 radians, 0, negative 1. Well, at pi over 2, the x-coordinate is 0. So then for the secant of pi over 2, this would be where our function is undefined. And same for 3 pi over 2. That would be down here at 270, where the x-coordinate is 0. Therefore, the reciprocal secant of 3 pi over 2 is also undefined. Okay. So with that being said, these functions are undefined at these given inputs. Where a function is undefined, we're going to go ahead and plot an asymptote. So let's graph our parent functions, y equals the cosecant of x and y equals the secant of x. And let's plot our asymptotes. Remember, for sine, the reciprocal is cosecant. Our asymptotes are at 0 pi, pi radians, and 2 pi radians. And the same is true for the reciprocal. The same is true for your negative angles. Negative pi radians, asymptote. Negative 2 pi radians, asymptote. Okay, for secant, our asymptotes are at pi over 2 and 3 pi over 2. Pi over 2 and 3 pi over 2. And the same is for your negative angles. Okay? And the way we're going to graph these is we're really just going to graph the reciprocal. So we're going to graph f of x equals the sine of x, which we had practice with last unit, and f of x equals cosine of x. And then you're hopefully going to see what these functions look like after evaluating a couple of these inputs. So remember, the sine of x, that would start at 0. And you're going to see that the sine graph, it's going to cross. Remember, these are all points. It's going to cross 0 here because that would mean it's undefined for cosecant. And then every pi over 2 is an increment, right? So this is our sine function, our parent function. And we're not going to sketch a straight line here. We're going to solid line. Apologize. We're just going to do a dotted line because this, once again, is not the shape of our graph. Okay. But let's talk about a couple of these inputs here. If you remember, the sine of pi over 4 gets you root 2 over 2. Well, now we want to know what the cosecant of pi over 4 equals, which would be the reciprocal, 2 over root 2. Which simplifies to root 2 when you rationalize the denominator, which is actually about 1.7. So if I go to pi over 4, which is right here, halfway between a half, 1.7 is somewhere up here. And the same is going to be true for 3 pi over 4. It's going to be up here. If you remember what happens with the asymptotes, the graph gets really close to but doesn't cross. So for cosecant, it's going to look like a parabola in all of these different sections of the graph, okay? The same is true when you get over here to 5 pi over 4, except now it's negative 1.7. 7 pi over 4, negative 1.7. Think about that. We're in our bottom two quadrants. So now this is going to open down. And you really don't need to keep plotting the point of 1.7 as long as you can sketch the original sine graph. That's why at the beginning of this lesson, I was reminding you, hey, you really just need to know the sine function because the reciprocal is just going to be flipped as such. And then let's define a few things. Domain, range. Okay. So domain is all real numbers where x does not equal all of your asymptotes. So your asymptotes would be 0, pi, 2 pi, and so on and so forth. So what you could do instead is you could just say 0 plus pi n radians. That way, every time n just stands for any integer, when you plug in 1, you get pi, 2 pi, 3 pi. These are going to be all of your asymptotes. The range would be y is greater than or equal to positive 1. Sorry, let's flip these around. Y is greater than or equal to positive 1. and we cannot write it like this because it's not including. So y is greater than or equal to 1, or y is less than or equal to -1. Okay. There is no amplitude because it doesn't go on. There's no maximum or minimum height from the midline. We do have a period length where it repeats. So the period length for this function, again, would be 2 pi, because if we continue this one more time, it would repeat over here. So just like sine, cosecant, the period length is 2 pi. And then really the domain tells you the asymptote. So if you want to put the asymptotes, it's the same as the domain. Asymptotes are at pi n. N standing for any integer. Okay, and we'll practice listing the asymptotes again as we continue practicing these graphs. Okay, let's try our secant graph. Remember, the same is true. We're going to start by graphing f of x equals the cosine of x. Cosine starts at 1. Remember, at cosine of 0 pi radians, we would be at 1. And then it starts by going down. Hopefully you notice at every asymptote, your reciprocal function should be crossing, hitting the x-axis at 0. Remember, we're only going down to -1 and +1 because the amplitude is 1. We haven't changed it yet. Let's put a dotted line on here. I completely messed up this side of the graph. I apologize. Let me fix that. We should have started down here at 0. Good. And now we're crossing at 0 at our asymptotes like we should be. Okay, here's our parent function sine or cosine graph. And then the same thing. If you were to evaluate the cosine of pi over 4, we would get √2/2. The reciprocal then, secant of pi over 4 would equal 2/√2, and we already talked about over here that that's about 1.7. So if I go to pi over 4, and negative pi over 4, because we are in quadrants 1 and 4, they're both going to be positive 1.7. You see the same kind of shape of your graph, this parabola shape. And I really don't need you guys to plot more points than just the reciprocal graph, and know that it's this U shape. It approaches your asymptotes kind of as such here. Okay. You can hopefully see that the function is repeating your period length from -pi/2 to +3 pi/2, which is again a period length of 2 pi, just like the reciprocal. So period length of 2 pi. Range would be the same. The range is y is greater than or equal to 1, or less than or equal to -1. Domain is going to be like your asymptotes. So for the domain, all real numbers where x does not equal, you could start really wherever you want. That first asymptote, let's look at pi over 2. Does not equal pi over 2. And then we would just put n, right? Because if you plugged in 1, you get pi over 2. If you plugged in 2, you would get your 3 pi over 2. Okay? So x cannot equal pi over 2n, and then for your asymptotes, we would just list them all out. Pi over 2, 3 pi over 2, negative pi over 2, and so on and so forth. Okay? All right, let's introduce kind of our newest function today, tangent, and then we'll graph the reciprocal, and then I will let you guys pause the video and have plenty of practice with some transformations on here. So again, I know this is new. It'll take some practice, but just take your time and work through the practice examples. Okay, remember that tangent is, let me kind of separate this here. Tangent is undefined where x equals 0. Because if you remember, the tangent of theta is the ratio y over x. So two places where x equals 0 that we listed up above, that would be pi over 2 and 3 pi over 2. Okay. Cotangent of theta would just be the opposite. Cotangent of theta is undefined where whoops, I was thinking y in my head, where y equals 0. Because cotangent is the reciprocal, x over y. We have a couple places where y equals 0 on our unit circle. That would be at 0, pi, and 2 pi. So hopefully you notice these asymptotes are similar to the functions that we graphed up above. That's why we're doing all of these last 4 trig functions today in the same lesson, okay? So for tangent, let's go plot our asymptotes at pi over 2, 3 pi over 2, negative pi over 2, and negative 3 pi over 2. Okay, for cotangent, 0 pi, pi radians, 2 pi, negative pi, and negative 2 pi. Okay. All right, we need to maybe evaluate a couple of tangent and cotangent ratios to maybe see the general shape of this graph. So let's do the tangent of pi over 4 and the cotangent of pi over 4. Remember, at pi over 4 for tangent and cotangent, because the x and y are the same, it's root 2 over 2 over root 2 over 2, which just equals 1. Same for cotangent of pi over 4. It's just going to equal 1. So for our graphs, and we know that the tangent of 0, for tangent of 0, let's list that out over here as well. Remember, on our unit circle, that's right here where our point's 1, 0. So the y is 0, the x is 1. So the tangent of 0 is just 0. We just talked about the tangent of pi over 4 being 1. And the tangent of negative pi over 4, you're going to be down in quadrant 4 where 1x is positive and the y is negative, so it would be negative 1, and your graph would look like this. And if we just continue that, pi, again, would be 0. It would look almost like your cubic graph. And then again, 2 pi, it's at 0. 7 pi over 4 at negative 1. And so on and so forth. I want you guys to notice one thing that's different for tangent functions. Tangent functions repeat, they're periodic after a much shorter period than sine and cosine. So that would be from negative pi over 2 to pi over 2, so the period length would just be pi. Your increments, same thing. So your increments, you could still graph increments like we did for sine and cosine functions. Take the period length, divide by 4, because the period lengths or the increments are where that graph changes. So up 1 and down 1 on both sides. Just make sure we know it's not a straight line. Our asymptotes. Just want to make sure in our book I'm listing these out the same way that you guys should be doing on here. So our asymptotes, we should be listing them as, yeah, perfect. Pi over 2 plus pi n. Pi over 2 plus pi n. Sorry, not divided by n, but plus pi n. Let's fix that up here. That should have been the same for secant. Pi over 2 plus pi n. And you can see that they begin to repeat, because if I plugged in 1 here, that would be pi plus pi over 2, which is 3 pi over 2, and they would continue. For cotangent, going to look very similar. If I wanted to evaluate the cotangent of, let's do pi over 2. Remember, pi over 2, we're now up here at 90 degrees where the coordinates are 0, 1. And for cotangent, that's x over y. So that would mean 0 over 1. So cotangent of pi over 2 is 0. And then let's be careful, because pi over 4 is still positive 1. So it's not going to look like exactly the same to tangent. It's going to look like it's been reflected. And now when we go to 3 pi over 4, it would be in quadrant, we'd be over here in quadrant 2, where the x is negative and y is positive, so we need to be negative. So our graph would look like this. Okay. And one last period. Okay. Again, period length is from 0 to pi. The function repeats, so the period length is pi. Our increments are pi over 4. And then your asymptotes. These ones are a little bit easier to write when it starts at 0 and pi. It's just pi n. Asymptotes at every pi n. If you plug in 0, you get 0. If you plug in 2, you get 2 pi, 1 pi. Perfect. So similar shapes for tangent and cotangent. One just shifted over and then reflected over the y-axis, okay? So what I'd like to do now is just finish up with you guys graphing each of these functions with some transformations applied. So I'm not going to write the transformation notation again. It's the same for sine and cosine, what the a, b, h, and k do. Maybe let's just do one of these together. Let's do number 2 together with you guys. Okay. For number 2, we have a couple shifts here. So this negative is going to make it reflect over x. We've graphed that before. This 1/3 is going to change your period length. It's going to horizontally stretch it. And then the 2 is going to be like a vertical stretch. It's going to change the, I know there's not really an amplitude, but it's gonna stretch it, and you'll see what that looks like on your graph. Instead of going 1 up 1 over 1, it's going to be up 2 over 1. Okay. So what I'd like us to do is to first find the period, then our asymptotes, then our increments. And then our asymptotes, and then we'll go graph. Okay, so normally the period length is pi, but because it's being divided by 3, our inputs, so pi over 1/3 actually becomes 3 pi. So we have a period length of 3 pi. So we might be a little bit off our graph here. That's okay. Our increments, 3 pi over 4. Okay, so 3 pi over 4 is right here. Still just dividing by 4. And then our asymptotes, remember for cotangent, our asymptotes are at pi n. That is going to change with this period length. So we know that we have a starting asymptote at 0 for cotangent. That doesn't change. We haven't shifted left or right at all. But our next asymptote is not going to be until the end of this period length. So that's all the way down here at 3 pi. So we're going to be somewhere off our graph. I'll just put it all the way down here for now. So our asymptotes are actually at 3 pi n. Okay. No matter what we plug in for n, they're going to repeat asymptotes at every 3 pi. So 6 pi, 9 pi, 12 pi, 15 pi, so on and so forth. And then if our increments are pi over 4 and our amplitude is 2, remember right in the middle of 3 pi and 0 is going to be our point on the x-axis. So that would be right here at 3 pi over 2. I know it doesn't look like that in the middle, but because I'm shifted over a little bit too far, ran out of room. Normally, the function would look like this, where it's going down, but because we've been reflected, now we need this point over here instead of up here because it's been reflected, and then same over here. And this point would actually be over at 3 pi over, it would be over here at every 3 pi over 4. So 3 pi over 2 plus 3 pi over 4. Let's change this to 4. So 6 over 4. So it would actually be over here at 9 pi over 4. Up here at 2. And really spread out because this function was stretched. And then the same on the other side at negative pi over 2. We're going to do a rough sketch because we're going to be off our graph. Here's our 3 pi over 4. Down here. Okay, but really stretched out, okay? I don't really want you guys to change those graphs. You can keep pulling them from Google. That way you can see the full shape and what these transformations do to these functions. Okay. Please pause the video. You just have 3 last examples to do. List out the period length, the increments, the asymptotes for tangent and cotangent, and then secant and cosine. Remember, graph the reciprocal. Okay, pause the video, work these out, and I'll check your solutions with you in just a sec. Okay, for number 1, the period length should have been pi over 2, because this 2 in front is actually going to be, it's going to horizontally compress it. The increments were every pi over 4. And then its tangent. We're going to list our asymptotes after we graph this function. But you remember for tangent, it always starts at the origin. And then our increments would be, this is a pi over 4. So I would have a point up here, right? And I would have a point down here. And then it's going to be compressed together. I'm sorry. Our increments are pi over 8, pi over 2 divided by 2. So this is actually where our asymptotes are going to be at pi over 4. Because our period length is pi over 2. So halfway in between is pi over 8. Let's label that so you guys have it on here. So it's going to be a little bit more squeezed together. I just need you guys graphing one or two period lengths. Let's do one more on this side. And this would be our function. Okay, so the asymptotes are actually at pi over 4 plus, and then they begin to repeat, so pi over 4, 3 pi over 4. So they repeat after every half pi n. So pi over 4 plus a half, or 2 over 4 would be 3 over 4. And then they keep repeating, Okay, for number 3, remember, graph the reciprocal. So you want to graph f of x equals -2 times the cosine of 4x. Period length, normally for cosine it's 2 pi, but because of the 4 it's 2 pi over 4, so pi over 2. So this is going to be really squeezed together. Our increments, just like our previous example where the period was pi over 2, our increments are pi over 8. Remember, to get the increments, it's just divide by 4. Let's go graph these on here. Normally, we would be starting up here at 1, but it's a -2 for cosine, and now we're going to go up. Every pi over 8, so this is a pi over 8. Then up here to pi over, another pi over 8, here, back up. Everywhere you cross the x-axis is an asymptote. Remember, where cosine equals 0, secant is undefined. Let's do the same on this side. Pi over 8, pi over 8, pi over 8, pi over 8. Everywhere you cross the x-axis is an asymptote. Now this function is tough because it's super squeezed together. Let's do it in a different color here. Here are your parabolas. Really narrow. Because of that 4, it was horizontally compressed. Okay, and we have something that looks like this. Last thing we should list is all the asymptotes. So our asymptotes are at, well, our first one's at pi over 8. And then our next asymptote would be at, let's see here, pi over 8. This is pi over 4. Would be at 3 pi over 8. So we just added a fourth plus pi over 4. Let's change that to pi over 4n. Okay. You can also change this to pi over 2n if you want. Okay, we just have one last graph to do here. 3 times the cosecant of -x. Remember, this is the reciprocal of sine. 3 times the sine of -x. We've never had a -x before. It's really going to reflect, this is a reflection over the x, but it's going to look the same as a reflection over the y. Okay. Let's go graph this function. The period length is 2 pi. We didn't change the period length at all. The increments, therefore, are pi over 4, because 2 pi divided by 4 is pi over 2. Sorry, pi over 2. And then asymptotes we'll list at the end after we graph our function. We would start at 0, go up to 3 because of that amplitude. It's not really an amplitude because we're graphing cosecant, but we're going to graph this function first. So we're going to go up to 3 at pi over 2. Those are our increments. Oops, I apologize. We reflected, so we need to go down to start. And then pi over 2, we'd be at pi. They're up 3, and then down to 2 pi. Same on the other side. Up to 3, down, down, down. All your asymptotes are where the sine graph is 0 or crossing the x-axis. So we want to plot our asymptotes. And we want to sketch a dotted line of what our sine graph looks like. Okay, hopefully you can see the reflection, because normally sine would look like this, but because it's reflected, it does not. And then you can just draw all of your parabolas from here. Okay, so our asymptotes are just, this one's nice and easy, just pi n. Every pi n radians, you have an asymptote. 0 pi radians, 2 pi, 3 pi, 4 pi, so on and so forth. Okay, as you can see, graphing takes a while. Take your time on the homework. Use Desmos graphing calculator if you need help. That should be able to help you out. Come back and look at your notes. Use your textbook examples for help if you need them. And I will answer any questions you guys have during office hours. Good luck.